I'm a professional mathematician and we're going to evaluate this y limit here. So here we have the limit x goes to 0 of x squared times 1 plus 2 plus 3 all the way up to the floor of 1 over absolute value x. So what does this even mean? So just briefly recall, the floor of a number is the greatest integer less than or equal to that number. So the floor of 7.2 is going to equal to 7. The floor of something like negative 6.3 is going to equal to the greatest integer less than or equal to negative 6.3 is going to equal to negative 7. And then the floor of 8 is going to equal to 8. Okay, so you can just see it's the greatest integer less than or equal to that number. Okay, so that's what the floor is. So here we have this sort of weird sort of expression, and I'm going to sort of walk through how to do it. I'm going to show you two ways. The first is super intuitive, the second is super slick. So make sure you watch for the end for the second, because you're going to love that. And so let's just dive right into it. So the way I like to think about it is to actually understand what's going on here. The floor of 1 over absolute value x, we want to think about x in certain ranges because the floor is a discrete function. So we'll see what that means. So basically, if we take x in the range of 1 over n plus 1 is going to be less than x is less than or equal to 1 over n. Okay, let's say the absolute value of x. Okay, so the limit is sort of x approaches 0 both from the right and the left. So we're going to work with the absolute value of x. Of course, here you have x squared, so that's always non-negative. Absolute value x is non-negative, so it won't really matter for our reasoning that x is basically a two-sided limit here, but you write it in this range, and why I'm doing that is if we then take reciprocals, if we take 1 over absolute value x, the inequality flips, remember? So we're going to get n is going to be less than or equal to 1 over absolute value x is going to be less than n plus 1. And now you see that in this range of n to n plus 1, the floor of 1 over absolute value x is going to equal to n. Okay, so therefore in this case, we know that the floor of 1 over absolute value x is going to equal to n, and that's very convenient. So that allows us to see that imagine x is in this range, okay, absolute value x is greater than 1 over n plus 1 and less than or equal to 1 over n, we're going to actually be able to make this limit concrete. And don't forget to hit that like button if you're enjoying this dissection of this problem, and also to see the super slick way at the end. You're going to love that. So let's just actually now work out what the limit is. So imagine this expression, okay, imagine this expression when x, absolute value x is in this range. Well, we're going to have x squared multiplied by 1 plus 2 plus 3 all the way up to n. And that's something concrete, okay? That looks something concrete, that when absolute value x is in this range, we've got that expression. But to find the limit, you know, we can't have an n and an x. Limit x goes to 0. So we want to sort of understand how to sort of estimate the x squared. So when x is in this range, absolute value x is in this range, we know the following, okay? We can square both sides, okay? All sides of this inequality. So we get that 1 over n plus 1 squared is going to be less than x squared is going to be less than or equal to 1 over n squared. Okay, so we get that. Now if we multiply that inequality with 1 plus 2 plus 3 up to n, we're going to get a nice bound for our function. So let's now do that. So we're going to get, so let's now work that out. So we're going to get 1 over n plus 1 squared times 1 plus 2 all the way up to n, right? That's going to be our expression. We're going to multiply this inequality by 1 plus 2 plus 3 up to n. This is going to be less than x squared times, now we're thinking about absolute value x being in this range. 1 over n plus 1 less than absolute value x less than or equal to 1 over n. So in that range, we know that this expression 1 plus 2 plus 3 up to n is just 1 plus 2 plus 3 up to the floor of 1 over absolute value x. So we can literally write this as our expression in our limit plus the floor of 1 over absolute value x. And then that's going to be less than or equal to 1 over n squared times 1 plus 2 plus 3 all the way up to n. Okay, so again, this is in that range when absolute value x is between these numbers, but of course, as n goes to infinity, that corresponds to x going to 0. So now using that inequality that we've got, we can now figure out what the limit is. All right, so we know that now if x is in this range, 1 over n plus 1 is less than absolute value x less than or equal to 1 over n. We know that in that range, as x goes to 0, we can correspond the limit to n goes to infinity. Okay, so we can now figure out limit n goes to infinity of these two expressions, estimating, bounding the middle term, and then we can squeeze them together using the sandwich theorem. So if we observe what is limit n goes to infinity of the leftmost expression, 1 plus 2 plus 3 up to n is n times n plus 1 over 2. So we're going to get 1 over n plus 1 squared times n plus 1 over 2. And of course here, if you have this expression, you can cancel off the n plus 1 here, and you get limit n goes to infinity of n over n plus 1. So you get limit n goes to infinity of 1/2 times n over n plus 1, which is just going to equal to half. Okay, so that's number 1. And number 2, for the second limit, for the limit on the rightmost side, we get limit n goes to infinity of that expression is going to equal to 1 over n squared times n plus 1 over 2. And again, you can cancel off the n's. So you can cancel off the n's here, and you get n plus 1 over 2n. Okay, and again, as n goes to infinity, that's also equal to half. So because both the terms here and here, as n goes to infinity, which corresponds to x goes to 0, both of them approach half, the middle expression approaches half, and therefore this limit is going to equal to half. Very, very cool, right? I find that very cool that we could just calculate that. And don't forget, as I said, to hit that like button, maybe hype the video. You know, if you have the hype feature available, that makes a huge difference to change lives through math education. I'm going to now show you a slick way. Okay, this looks a little bit like, to give you the intuition of what's going on, I'm going to make it slick now. So this is going to be super beautiful. All right, now here's the slick way. Okay, it's super elegant, and this is the way that, mathematics, how it's done is first you look at the intuition, then you find this super slick and easy way. Okay, so the super slick way is the following. We're going to observe the following inequalities on the floor of y. Okay, so we're going to observe that the floor of y is the greatest integer less than or equal to y. So of course it's going to be less than or equal to y. It's also going to be greater than y minus 1. Okay, whatever y is, it's going to be greater than y minus 1. So if you think about it, it's actually a strict inequality. You don't need the strict inequality, but if you think about something like the floor of 8, that's 8. And the floor of 7.9 is 7. So the floor can never reduce by more than 1. Okay, so that's why we have this inequality. And now we're going to use that to understand what happens to the 1 over absolute value x, the floor of that. Okay, so here's what we're going to do. And this just looks super slick. Okay, so we're going to write this limit as limit x goes to 0 of x squared times, what's this expression going to be? It's the n times n plus 1 over 2 formula, right? We know this is going to be a positive integer because we know 1 over absolute value x is going to be greater than or equal to 1. So we know the floor is going to be greater than or equal to 1, so it's a positive integer. So we use that formula that we just did in the previous argument. It's going to equal to 1 over absolute value x, the floor of that, times the floor of 1 over absolute value x plus 1 divided by 2. Okay, so that's our limit. So we're actually doing some algebraic manipulations to finding this limit. Okay, so we've got that far. Now we're going to do our estimate. So it's all the same thing we just did intuitively, but in disguise. And I just want to give a huge thank you so much to Alex and Nathan for gold support on Patreon and Stephan for ruby support on Patreon, as well as to my YouTube channel members, Aman, Rob, Shabid, and Bernard for their ongoing support. It really makes a world of difference. The exclusive perks available is my way of saying thank you, and I'm really doing everything on my own on this channel, and all the support really helps because I want to outsource a lot of the work to really ramp up production. Every video takes time to edit, to create thumbnails, descriptions, to record, to come up with ideas, and it's all stuff I do in my free time. It takes a lot of time, and so every support really helps because then I can start outsourcing a lot of editing work, focus on the math, and really deliver lots of high quality content to you. And if you support, you have access on Patreon, you have access to a members only Discord server, priority replies to YouTube comments, no matter how you support, and so much more. Okay, a personalized thank you message and my gratitude. So I'm so grateful for all the support. So let's now get into how to actually understand this with the estimates that we just had here. So what we can do is we can observe that. So I'm just going to write it as follows. We can take x squared is going to equal to the absolute value of x squared. Okay, so that's number 1. And now we can think about the following. We can think about the absolute value of x multiplied by the floor of 1 over absolute value x. Okay, so multiplied by the floor of 1 over absolute value x. We use this inequality. We know the floor of anything is going to be less than or equal to that thing. Okay, so this is going to be less than or equal to absolute value x times 1 over absolute value x, which is of course equal to 1, right? So it's going to be less than or equal to 1. And similarly, it's going to be greater than absolute value x times 1 over absolute value x minus 1. Remember, the floor of anything is greater than that thing minus 1. So we can write this as greater than absolute value x times 1 over absolute value x minus 1, which of course is just going to equal to 1 minus the absolute value of x. Okay, so that's what we have. So we have that inequality, 1 minus absolute value x less than absolute value x times floor of 1 over absolute value x is less than or equal to 1. So again, you can kind of see that, this is sort of shielding some of the intuition, but we're sort of working like a mathematician with an elegant kind of argument. And so now that we've got that far, we can now actually apply it to this inequality. Okay, so I'm just going to do that now here. So this expression here, I've just moved it to the right side of the board. We can use that estimate. Okay, so we know that X squared you can say is just absolute value x squared. Like it's a non-negative number. So absolute value x times floor of 1 over absolute value x less than or equal to 1. So we've got two absolute value x's here. Absolute value x times that is going to be less than or equal to absolute value x times this is of course less than or equal to 1, and absolute value of x times 1 is less than or equal to absolute value x, or it's equal to absolute value x. So basically we're just going to get 1 plus absolute value x, okay, divided by 2. That's what this is going to be, less than or equal to. Okay, so absolute value x times this expression is less than or equal to 1 plus absolute value x. Absolute value x times this expression is less than or equal to 1. So we get that. Similarly, and this is an exercise, you can actually bound this thing. Okay, so again, absolute value x times this is greater than 1 minus absolute value x. And absolute value x times this expression is going to be greater than 1. Okay, that's just an exercise to sort of see you're following along. So you divide that by 2, and now we use the sandwich theorem. So basically as x approaches 0, this approaches 1/2, and as x approaches 0, this approaches 1/2, so therefore what's in the middle approaches 1/2. Pretty elegant and cool, right? So hope you loved that video. Drop me a comment down below, which approach you like. Did you like the first one or the second one that was slick, or the first one that was more intuitive? Which one do you prefer? That gives me good feedback, and love to hear if you have any thoughts on this problem, how you'd approach the problem. I'd love to hear that. Now I've got 2 fun videos for you. You're gonna love this. Okay, my channel has math across all topics and levels. I want to show you something you're gonna love. It's going to be limit n goes to infinity. It's another limit. It's a little bit wild. It's going to be sum k varies from 1 to n of 1 over n plus k. Okay, so what's going on here? There is a summation variable of k and a limiting variable of n. If you want to see that dissected, it's so beautiful and so simple. You're going to love it. Check it out. It's going to pop on the screen here. Very popular video on my channel. And another popular video on my channel is the Brouwer fixed point theorem. Okay, so I've given a little bit of insight into the subject of algebraic topology in that video, at the end of that video, but I also explain how to prove it rigorously. It's rigorous math. It's pretty fun. You're going to love it. It's going to pop on the screen here. Check it out.